Example number 3. The position of an object moving in a straight line is given by the following equation, where t is greater than or equal to 0, because time cannot be negative, where t is measured in seconds and distance is in meters. The first question says, when is the object at rest? If it is at rest, then v of t is equal to 0. Well, I have s of t, I can find v of t. v of t is equal to 6t squared minus 42t plus 60. I want to set it equal to 0. I see already that there's a common factor of 6, so I'm left with t squared minus 7t plus 10 is equal to 0. I want to multiply to 10 and add to negative 7, so my two numbers are t minus 2 and t minus 5 is equal to 0. Notice that t is equal to 2 and t is equal to 5. So at 2 seconds and at 5 seconds, this object stops. The next question is, when is the object moving in a positive direction? This is leading us into next class's note, but it is also an opportunity to apply next class's lesson. So, when something is moving in a positive direction, I need to worry about the velocity. I already have the velocity broken down into its factors. So what I'm going to do is I'm going to make a sign chart. The sign chart works like this. Draw a line at the bottom. Use the two numbers where the object is stopped at the bottom. On the left-hand side, you're going to write t minus 2 and t minus 5, the factors that you have. Now, the 6 is not important. The reason the 6 is not important is that it does not change anything. It's a constant number. It doesn't change. If it was 6t, for example, that would also go in the chart. Now, pick a number less than 2. A great number is 0. I can't choose a negative number, notice, because t is greater than 0 in the question. So 0 is the smallest number I can pick. 0 minus 2 is negative. I don't really care what the number is. I just care if the number is positive or negative. 0 minus 5 is also negative. Great. Pick a number between 2 and 5. Let's say, for example, 3. 3 minus 2 is positive, and 3 minus 5 is negative. Pick a number bigger than 5. So, for example, 10. 10 minus 2 is positive, and 10 minus 5 is also positive. Here's where you do a little bit of sign thinking. A negative times a negative is a positive. A positive times a negative is a negative, and a positive times a positive is a positive. This object is moving in the positive direction in this region and in this region. Now, how do I write that? Let's say I want to write it using the notation I just learned above. So, square bracket 0 because nothing is less than 0, and 2, round bracket. Why is 2 a round bracket? Well, because at 2 it's stationary, it's at rest, it's actually not going anywhere. So I can't include the 2, it cannot be a square bracket. And then it's 5 with a round bracket also for the same reason as the 2, comma, all the way to infinity. And because infinity is such a large number and we actually don't know where it ends, you can't contain that either. So that's a round bracket as well. So that's the way to say that it's moving in a positive direction. If you'd like to write it the old school way, you're more than welcome to. That's 0 is less than or equal to t, which is less than 2, and t is greater than 5. That's another way to say it. Okay, next question, C. Find the total distance traveled in the first 6 seconds. Well, we know that this object goes forward for the first 2 seconds, it stops, and then it goes backward for 3 more seconds, from 2 seconds to 5 seconds, and then it goes forward again from 5 seconds to 6 seconds. But whether it goes forward or backward, it doesn't matter. It's still covering distance. So I want to make sure that the distance that it covers is always a positive distance, regardless of the direction that it's going in. So how do I take care of that? Well, what I'm going to do is I'm going to make sure that I take the absolute value of things, but I want to find the distance between things. So for example, I want to find the distance from, let's say, 0 to 2. I want to find the distance from 2 to 5. I want to find the distance from 5 to 6. Now here's where your number crunching gets involved, and you go right back to the top to the initial equation. Plug in 0 into the displacement equation, and you get out 0. Plug in 2 into the original equation, and you get 52. Plug in the rest of the numbers and see what you get. Now, this becomes negative 52, but because I take the absolute value bars of it, that's 52. This is 27, and this is 11. If I add up all these numbers all together, I get a total distance traveled of 90 meters. So not too bad. It's a lot of number crunching, and it's very science specific, only because there is a very likely opportunity that you're going to make a mistake just doing the number crunching, for no other reason than that. But the question itself isn't that challenging. So let's try another one, pretty similar. If you'd like to pause the video and try this one on your own first, before jumping in with me, that's great. The position function of a cheetah moving across level ground in a straight line chasing after its prey is given by the following equation. Lovely, where t is measured in seconds and distance is in meters. What is a cheetah's velocity after 1 second? Well, I have the displacement equation, so the first thing I need to find is the velocity equation. So v of t is equal to 3t squared minus 30t plus 63. If I sub in v at 1 and v at 4, tell me what you get. Hopefully you get something around, let's say, 36 meters per second. And if I sub in 4, I think it's negative 9 meters per second. Then it says, when is the cheetah momentarily stopped? Well, when is it stopped? In order to find when the cheetah is momentarily stopped, again, I need to work with the velocity equation and find when that's equal to 0. I've already got the velocity equation. I see that I can take out a common factor of 3. I'm left with t squared minus 10t plus 21. I want a product of 21 and a sum of negative 10. My two numbers will be t minus 3 and t minus 7. So I know it's momentarily stopped at 3 seconds and at 7 seconds. I want to know when the cheetah is moving in a positive direction. So make your sine table. Everybody work through it. Make sure you set it up the same way that I am. Pick a number less than 3. 0 is a great number. Negative, negative. A number between 3 and 7. 5 is a good number. Positive, negative. A number between 7 and infinity. 10 is a good number here. Positive, positive. So it's positive, negative, positive. This cheetah is moving in a positive direction from 0 to 3 and 7 to infinity. When is the cheetah moving in a negative direction is the next question, and I don't need to make my sine table again. I can simply look at the one that I've just made, and I can say from 3 to 7. Find the position of the cheetah after 10 seconds, which means I want to know where it is after 10 seconds, so s at 10. That's 10 cubed minus 15 times 10 squared plus 63 times 10, which I believe is 130 meters. Then it says find the total distance traveled, it's missing a t, by the cheetah during the first 10 seconds. Again, remember at 3 seconds and at 7 seconds it stops and changes direction, so we need to account for that. So I want to go s at 0 minus s at 3, s at 3 minus s at 7, and s at 7 minus s at 10. 0 minus 81, 81 minus 49, and 49 minus 130. That's 81, that's 32, and that's also 81. So that gives me a grand total of 194 meters. Fantastic.